Welcome to all. Today, or from this class onwards, I am starting reactions for cantilever beams. But before I start one by one problems or questions, example for different types of loads, first I am going for a master question. Not one master question. See, class, master question. Maybe total 6 are there. Maybe total 6. I will tell the reason why 6 required. If you want to have no difficulty in future, if you want complete control for reactions, support reactions for cantilever beam, you should first go through lecture 50, previous class, introduction part for cantilever. 51 is this class, where I am solving master question 1, that's all. 52 and 53, master question 2 here. Maybe here I will solve 4 master questions, 53, and if requirement is there, 54 also. See, or plus if requirement is there, 54. Once I finish all the master questions, then onwards, every class I will write somewhere. Those who are not gone through completely through master questions, including 50, that is 50 to 53 or 54, for them, if any difficulty is there, it is their problem, not my problem. I give so much effort. I put so much of effort so that the education is complete and systematic. Everybody gets full knowledge. Still, if you cannot go through everything, means you are the loser. Of course, it will hurt me if someone tells it's not clear, somewhere in between, this doubt is there. It will hurt me, but I know it is their mistake. So, everybody go through each and everything. Start. Why master questions? Maybe 6 class. Why? Because there are 2 procedures are there for cantilevers. One is systematic solution. I told earlier, last class. Other one is somewhat shortcut, where you need only calculator. No writing, nothing. I will explain both. Systematic is for those who are studying everything in order. Shortcut is for those who master the systematic and then they want to learn more. Okay. First time, I think after a long time, I wrote the question here. See, a beam, I have not told cantilever, a beam of length 4 meter is fixed at left end. 1 minute now. I will remove all this, and I seeing that question, seeing that words, I will prepare the question here. In front of you only, I will prepare the question. So that you should know how to prepare the question. See, this all I am removing now. This all I told, you should go through. Okay, now, master question 1. Even this space also I require. So you can write here. Now color change is no problem. I already told. This is master question 1. Okay. See there. A beam of length 4 meter. I have not told is of, because grammar problem. A beam of length 4 meter is fixed at left end and free at the right end. So therefore, I will put the beam here, somewhere here. Fixed at left end and free at the right end. Just to understand, I will put double line. See, very slowly I will explain so that everything is clear. So total length, I will mark here. Somewhere outside, I will mark total length. 4 meter. Okay, now further data. It is loaded by an UDL of 60 kilonewton per meter, 1.8 meter long, starting at 0.5 meter from left end. So what you have to do? 4 meter, this is 2, this is 1, this is 1. From left side, you give a gap of 0.5 meter. From there, you start a UDL of 60 kilonewton per meter, 1.8 meter long. So it won't come up to center. Okay, maybe up to here, sufficient. It's a bigger I will write. Okay, no problem. Next time I'm putting bigger. Okay. The loaded length they told is how much? I write here now. See, the loaded length they told is 1.8 meter and load starts at 0.5 meter from left end. Okay. And a constant next, comma, a concentrated or point load of 100 kilonewton at 2.6 meter from left end. So from left end, you go for a length of 2.6 meter. See, 0.5 plus 1.8 is 1.8 plus 0.5, 2.3, 2.6, slightly more. Okay, sufficient. Somewhere here, there's a point load. I forgot to write the UDL here. It is 60 kilonewton per meter. This point load is 100 kilonewton. I'll check the camera first. This is, they told, 2 point, how much it is? 6 meter. So you can do one thing. This gap you can write later. I won't tell now. Okay, then further. See, UDL point load over. I decided to introduce a triangle load also for master question. Later, everything will come systematically. First point load at the free end, somewhere in between, full UDL, partial UDL, then in order, full in UVL, partial UVL, all will come later. But this is master question. UVL for a length of 1.2 meter from right end. So, from right end, the UVL length is, scale is not maintained now, 1.2 meter is length UVL. Okay. That is length from right side. How is the UVL? With the maximum intensity of 80 kN per meter at the right end. So, right end maximum intensity of here. 80 kilonewton per meter. I have to check the board once, camera once actually. 80 kN per meter right end. And zero intensity at the left end of the UVL here. See, they told UVL is for a length of 1.2 meter. At right end of UVL maximum intensity, zero here. This is the UVL. Okay. Now this gap I require later. Okay, then. And zero intensity at left end. Find reactions at support. The question I am going to remove now. Why? I want to write neat sketches now so that I can calculate. There is some writings there that is testing of the ink. Hope it is not visible in the camera. If visible, I remove it. Okay, I'll remove that one. I think you cannot see it. I wrote some testing the ink. Okay, now, see, you write a heading here to understand correctly. See here. To understand what is this one. This is solution for master question 1. Again, I write here. Actually, not required. This is master question 1. Okay, over. This is what I have sketched here is, okay, little more, I can shift it little higher. Not required, 4 meter. Okay, everywhere I wrote, okay, I write 0.5 meter here. Looks very ugly. One place you write below, one place you write above, okay. 1.2 meter. Okay, now, this is beam or, okay, I'll put full. This is the cantilever beam with given loading. What all I tell in the class, go through everything with patience. If not today, tomorrow, later, it will give you dividends. Escape and skip and randomly see, you will be the loser. Okay, now, I will go for reaction calculation. See, now, I will write here, solution. First, I will dictate something that you should write. This is fixed. So I will one thing now. This point I will call A. This I will call B. Intermediate points not required. Okay, I will tell this is C, this is D, this is E to understand later. Okay, this is F. E is here. This is E. This is F. Okay. Now, we are asked to find support reactions. This already I told earlier for you. You should go through previous class. For a fixed set support, there are 3 possible reactions. Vertical reaction, horizontal reaction, and the most important, reacting moment. So there will be a vertical reaction. So I write here now, let VA be vertical reaction. Next time I won't write reaction at, okay, that is the vertical reaction, comma, I can do one thing to make it easier, be the vertical reaction, comma, actually you make a note here, horizontal reaction is not there, still I will write HAB horizontal reaction. Actually we are not interested here, horizontal reaction, because master question, and MA, this is the most important, MA be reacting moment or moment reaction, reacting moment at fixed support, comma, name of the support is A. Okay. Now next I will go to first traditional solution. Okay, option 1 I will put here. Option 1 is traditional solution. Traditional spelling problem. Okay. I think TRA I think. These all no problem. Traditional solution. Or what you can call is systematic way, or the way we have done so far. What we have done. For that, we have to assume directions for reaction. See, one by one I will tell you. These all I told last class. Next class I will not tell. First decide direction for vertical reaction. Loads are acting down. That is action. Loads are acting down. So vertical reaction will be up. So right here, let us consider VA vertically up. Okay, 1 over. Then, comma, HA to right side. Anything. And very, very important, consider MA, I told, reacting moment at A in what direction? This you should be very careful. See, you can take any direction, your choice, no restriction, but people should not laugh. What you do is, I told you, put your finger at the fixed support. Then, see, all these loads will try to rotate in with respect to fixed support. Will try to rotate the beam with respect to fixed finger should be at the fixed support A in clockwise direction. You can write here if you want. What all I dictated, see, you can write here. All the loads are vertically down. Therefore, I am considering that is the action, reaction vertically up. Write in the bracket somewhere. HA, there is no problem. Take randomly. Then, always consider the fixed support. See how is the moment of all the loads. All the loads will create clockwise moment about the fixed support. Means if fixity is not there, it will try to rotate the beam with respect to fixed this point A in clockwise direction. That is the action. Therefore, to prevent it, that is for equilibrium, the reacting moment MA should be in anti-clockwise direction. It will be in anti-clockwise direction. You write this statement systematically. Okay, now, see, put the beam. Somewhere here I will put the beam. I will draw one more sketch to understand correctly. One more sketch I will write. Correct, understand. Now this time in the sketch you should be careful. This is A, this is B, this side B, this is 0.41, okay, 0.5 meter, 1.8 meter, then this is 2.6 meter. This is 1.8 and 0.5. I do not want cut distances. 1.8 plus 0.5 is 2.3. This is 2.6. Further is 0.3 meter, small distance. Then, see, if this is 2.6 meter, from here to here will be 1.4 meter. See, 1.4 meter. In 1.4 meter, this is 1.2, so this gap will be 0.2 meter. 0.2 meter. Somewhere little bigger I can write. Okay. I can make little bigger. Okay, to make clear. As clear as possible. This is B. So here 4, 1, 3. Okay. 0.5 meter, first point here, 0.5 meter. Next is 1.8 meter up to here. After 1.8 I told you, 1.8 plus 0.5 is 2.3. This is 2.6, 0.3 meter. One more gap of not scale, 0.3 meter. Then one more gap is there. See, that is this gap. This gap is, if this is 1.2 and this is, if this is 2.6, this is 1.4. 1.4 minus 1.2 is 0.4. 0.4 meter, and then this is 1.2 meter. So from here UDL will start. Here there is a point load. Here there is uniformly varying load represented by a triangle of intensity 80 kilonewton per meter. Then right here, this is how much? 100 kilonewton. UDL is 60 kilonewton per meter. I want all distances now. This gap from here to here is, I told you, 0.0 is given. I laid below the line, 0.5 meter. This loaded length of UDL is 1.8 meter. This gap to the point load is 2.6 minus 0.5 minus 1.8, 0.3 meter. I already explained. 0.3 meter. This gap is 0.4 meter. And this loaded length is 1.2 meter. Okay. A, B, C, D, E, F. Over. Now, as I assumed here, 0.5 meter, I want to write it upper side. Okay, suppose I can bring down. See, I am telling you, very slowly I am doing today, not in a hurry. Not hurry. You also have patience. When you learn something, always learn to have patience. Now, reaction red color, I am assuming VA in vertically upward direction. And useless, horizontal lastly. Horizontal reaction, I am assuming to right side. Actually, unwanted. I'll put here, the small HA. And the most important, I will consider reacting moment MA in anti-clockwise direction. I told very clearly, last time told, once again I am telling today, this is the beam for which you require support reaction. Now it is ready for solving. Now 1 minute now, let lengthy calculations are there. I do not want to check repeatedly now. Therefore, I will first use my calculator and check or get or obtain what should be the answer, so that I can save time of calculations later. Oh, see, there was a small mistake actually. This gap, I think I wrote 0.4. I don't know how it happened. This is 2.6. This is 4. From B to E will be 4 minus 2.6 is 1.4. When this is 1.4, when it is 1.2, this will be 0.2. I first wrote 0.4. Then what happened is, when I found the reactions, I got the answer. I did not see this sketch. First of all, I don't require that neat sketch, etc. I can look here, and I took my calculator and found here. But then, just to be sure, I checked moment about some other point, just for safer side, so that I do not want any mistake. But I got different answer. Then I started wondering, what is wrong? Then suddenly, the thief is caught. You see, when this is 2.6, this is 1.4, subtract 1.2, 0.2. I told 2.6 here, I took 1.6 here, it is 1.4. Some of you by this time might have already observed it. You would have told, suppose somebody is there with you, you would have told, see, he does not know how to get distances. Now, if you are told to your friend, now tell him, no, he knows it. Just to print mistake. Okay. Now, first, sigma unwanted. See, for today's class, this is unwanted. Unwanted for today's class. Unwanted for today's class. Because I told you, only sigma h0 is very simple. That special principle is not there. So anyway here, sigma h0, ha, that's all, no other load, equal to 0. So your ha will go. Next question onwards, this ha I am not writing. Why waste? I will write in the beginning only. Ha is not there. Okay, start. Now, I already assumed here. First see, so many people, they first take sigma V0 and sigma M0. Cantilever, it does not matter. But simply support beam, I told you, if you make sigma V0, VA, VB both will come. One equation will come. When you make sigma M0, one of the unknown will come. Then you have to substitute back in that first equation. Only one equation. Instead, you first apply this I told earlier. Sigma M0, one reaction comes. Sigma V0, second reaction comes. Here, I will maintain same tradition. Or take moment about A. See, those who want, write here. Algebraic sum of moments of the entire given force system. See, complete force system about any point 0, but we are taking moment about A. Why A? We will take clockwise positive. Why A? I will tell you now. See, if you take moment about B, MA and VA both will come. See, MA and VA into 4. You won't get the answer. You get the equation. But if you take moment about A, your VA into 0. You should know that much. Therefore, directly you will get MA. So, always take moment about the fixed end. You make a note. Or take moment where there is unknown moment. Unknown moment at A. So, take moment about A. Okay, start. Put the finger at A. One important now. See, there is a reacting moment here. Again, remember, later I am uploading one class, one series of classes. All basic concepts and important do's and do nots to be remembered for a structural engineer or structural engineering study. There I will tell, again and again I will tell, when you take moment, you have to consider the entire force system. Whereas later, when you find a bending moment, you have to look only one side. That is later. So sigma means, see, complete system. If you stand somewhere here, you have to look that side and also this side. If you look here, you have to look that side and also this side. So you can make a note here. Your face should be see right side, also see left side. For sigma M, your finger is here. See, finger put firmly here at A. Put the finger here. Finger here. Okay, now, force into distance. Distance should be from the point A. Start from there. Before that, make a light note. I should not explain too much. It will be insulting now. For this triangle load, actually not required. First of all, if I explain, someone will tell, sir, you are insulting us. Why insulting? Something you told thousands of times. Okay, see, the resultant load will come somewhere here. This is the line of action of resultant load. Remember, this is 2 by 3, this is 1 by 3. This load is area of the triangle. Here, resultant load will pass through center. This much note you make pencil. Okay, start. Half into 1.2 into 80. That is, see that is the half into 1.2 into 80 is total load into from A distance to line of action. 0.5 plus 1.8, 2.3 plus 0.3, 2.6. It is already there, 2.6 plus another 0.2, 2.6 plus 0.2 is 2.8 plus another 2/3 of 1.2. Or you can do one thing. From here, you want here. See, either you write 0.5 plus 1.8 plus 0.3 plus 0.2, that is 2.8 plus 2/3 of 1.2. Or total length is 4. From 4, you subtract 1/3 of 1.2. Both are same answer. Okay. Then, how direction? Clockwise. Then, 100 into 2.6. I won't explain. 0.5 plus 1.8 plus 0.3 over. Then plus clockwise. 60 into 1.8 is the total load into 0.5 plus 1.8 by 2. That side, everything over, you make a note taking moment about A, VA into 0, but HA also into 0, but this moment is there. It is anti-clockwise moment, so minus MA. Why minus? Because you consider clockwise positive. Now, this clockwise positive has no effect on the answer. I will explain it later. Okay, you solving, see all positive, negative, your MA, always write the answer with the sign. It will come plus. Okay, now, sigma V0, anybody can tell the answer, upward positive, only vertical load now, plus VA minus 60 into 1.8 minus 100 minus half into 1.2 into 80 is 0. Take that side, VA will come plus 256 kilonewton. Now, some note you have to write. What all I explained, if you are serious, you have to write. We considered VA vertically up, see here, up, and reacting moment MA to be in anti-clockwise direction. You applied sigma M about A0 with the clockwise positive. This clockwise positive has no effect on the answer. Even if you take anti-clockwise positive also, same answer will come. This plus sign has nothing to do with this sign convention. You do one thing. Once you finish this one, sigma M about A0, take out this clockwise positive and throw it out. Now, we got VA positive, MA positive. What is the meaning of that positive? When you find an unknown reaction using basic conditions of static equilibrium, you can use any sign convention. That I will explain later stages. That's why I told see master question 50, 51, 52, 53, 54, etc. Once it is over, I will start question number 1, 2, 3, 4 like that. I will tell master question over today. Therefore, right, this positive sign indicates that what direction you considered here, what direction you considered here is correct. Therefore, the real vertical reaction VA is 256 kilonewton. We considered upward, positive, correct. It is up, no plus now. And reacting moment MA, we considered like this, anti-clockwise. Answer came plus. Don't see sign convention here. Sign convention has no effect on the answer. Positive indicates that what direction you considered is correct. Therefore, your MA is 584 kilonewton meter in the same direction as considered. Make all this note. Then once you write all those statements, then you write the final answer. I will write the final answer somewhere here. Okay. This all I remove now. Okay, this is option 1. Okay. I will all remove now. I will write the final answer. See. I write here. After everything is over, right here. See from there, okay, come here. Come this side. Therefore, final conclusion now. We are writing the final verdict. Therefore, support reactions will be, you can write support reaction for the given cantilever beam, etc. You write will be as shown below. as shown below. Below I will show it. Final answer. See, this is the beam. Little bigger. Okay, this is the beam. Now too much time is not required. Wasted. See here, one uniformly varying load. How much all not required? You can see there. Then one point load here. One UDL here. That is not required. If you want to write everything, this is A, this is B. There is a VA you took upward. This is up VA equal to, we got plus now. Once you are entering the answer, assume direction is correct. It is upward of 256 kilonewton. And MA we considered like this. Yes, correct. Anti-clockwise it is. Your MA equal to as shown below. Okay, space problem. As shown below. MA equal to, no plus minus now. You got plus here, means correct. 584 kilonewton meter. This is the final answer as per option 1. See, this is the final result. Final result as per our option 1. Option 1. Now we will go to option 2. Okay, put one line here. Now some statements are there. Now go to option 2. Option 2, there will be plenty of explanation, but once you understand that one, it is very, very easy. Okay, now I will do one thing now. For option 2, I will remove all this. Nothing required. See, there you directly enter the reaction. See, everything you remove. Actually, you can refer the original beam only, but this cut distance required. So this time, next time onwards, we will refer original beam only. Okay. Over. Now, see. What you are right is, okay, I write here, option 2 once again. Okay, option 2, first put the sketch. Sketch, where? Right mark. See here, right mark. Put the sketch. Somebody will tell, sir, you will draw where you drawn it last time. So what? You are learning. Draw once again. Why should I rub and write this? Why should I rub and write once again same thing? Am I learning anything? I am not learning anything. Okay. Now, leave it. First, I will dictate so many things now. What all I dictate, you have to write. First, he told, first get horizontal reaction. Horizontal reaction. If it exists, right here, fixed support can give horizontal reaction. Reaction will come when there is an action. These are all actions. No action, nothing. Right? Right. Therefore, horizontal reaction at A equal to 0. You write it. Over. First I told, that's over. Don't write horizontal reaction. Then, now, next, get vertical reaction. Now see, sigma V first, vertical reaction. Okay, I'll put red color. Vertical reaction, that is VA, or vertical reaction where? At fixed support. I told 1000 times. Fixed support, A. That is, we have to find, what is the value of VA. Okay. I explained last time. Slowly I will tell once again. For that, what you do is, no SC in option 2. Today it will take some time. Later it will be very, very fast. Because by principle, but to understand that one, you require more explanation. Start. First you decide action. Action. Right. Action means given loading is the action. This UDL, point load, and UUL, they are the action. All of them are acting. You should write here that UDL, point load, and uniformly varying load, what all given there, they are action. So action means UDL, point load and that uniformly varying load. They are the action. All of them are acting vertically down. So find here. So find net vertical load. Vertical load. See, vertical load on beam. On beam. That is equal to, see here, downward load 60 into 1.8 is down plus 100 is down. Only loading now, no moment, plus half into 1.2 into 80, that also down, equal to 256 kilonewton down. This is your action. Action. Therefore, vertical reaction, there is only one vertical reaction. There is no sharing. Whatever is the loading on the beam, in a cantilever, everything has to come here. See, if you stand on a slab or floor where both sides beams are there, loads are shared. If you sit in the portico or cantilever, wherever you stand, load will be transferred to the support only. Okay, so therefore vertical reaction right here, which is opposite to the action, same magnitude but opposite in direction, vertical reaction at A, that is VA, will be equal in magnitude, you write here, is equal in magnitude to the total downward load action but opposite in direction. So 256 kilonewton up. Go back, where? Not home. Go back and enter. Enter money. Here, neatly enter here. Upward reaction VA equal to 256 kilonewton. Enter here. Over. Go back and enter. Okay, now I will rub these two now. I want more space. Okay, now horizontal reaction, vertical reactions are over. Okay. Now lastly, this is the most important step to get reacting moment at fixed support A, that is how much is MA, that is MA. Okay, start. First you consider action. Action means you should find, what all I dictate you right here. For first to find action means rotational effect about the fixed end. Therefore, put the finger, never by heart A, put the finger at the fixed end here. Okay, don't remove the finger. Start. Find net moment of all the loads about A. Net moment of all loads on beam about A, about fixed end, that is A, fixed end, that is A, equal to, see here, moment load multiplied by distance is 60 into 1.8 is the total load into 0.5 plus 1.8 divided by 2. This will be in the clockwise direction, plus, this is in the clockwise direction, plus space problem is there. I should start from somewhere here because I'll write here equal to, okay, space problem is there. 60 into 1.8 is the, no plus minus, see, 1.8 into 0.5 plus 1.8 by 2. See, this is the total load. This will be in clockwise direction. See, clockwise plus. This plus is not clockwise plus, summation plus. Okay. 100 into directly load 100 into 0.5 plus 1.8 plus 0.3 is 2.6. 2.6. This also clockwise plus moment of this load. This load first. Half into 1.2 into 80 is the load. Again, space problem is there. Okay, right here. Clockwise plus 1 minute. Check the camera first. I do not want to rub later. Okay, camera, no problem. Nothing to worry. Otherwise, what happens is, after recording is over, if it goes out of the camera, class is wasted. Plus, how much? Half into 1.2 into 80 is the total downward load into this load into this distance is 0.5 plus 1.8, 2.8 plus 0.8 is 2.6 plus 0.2 is 2.8 plus another from here to here is 2 by 3 of 1.2, or you can tell one more thing. What? From 4 subtract 1 by 3 of 1.2. That also will do. From 4 subtract. Now this also clockwise. So all together calculate. See, clockwise, 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 all clockwise. Calculate. No plus minus. 584 kilonewton meter clockwise. Okay, now some statement you have to write. Statement, I write here. That this is nothing but your action. Action. Considering moment about fixed end. Action. That is, all this load together will try to rotate the beam with respect to fixed end point A in clockwise direction by moment of 584 kN meter. So the reacting moment will be equal in magnitude but opposite in direction to the action, or therefore, see, reacting moment at fixed end MA will be right here, equal in magnitude but opposite in direction to the action will be 584 kilonewton meter. Action is clockwise, reaction is anti-clockwise. Okay. Now, space problem. Go back, not go back home. Go back and enter. Enter. Come here. Come here. It is not writing properly. Color has become very fade because of the ink problem. Okay. I want dark, but okay, available dark I will write here. Actually, it does not matter. You should not bother about color in my class. Okay. Anti-clockwise. This MA, right here anywhere. Okay. This MA, ayyo, not writing. MA equal to 584 kilonewton meter in anti-clockwise direction. See the answer now? What answer you got here? Same answer we got here. Now, this is first question. I will tell you, if I am solving this question, you see how much time I will take. I will honestly solve now in front of you, no cheating. I will honestly solve. If somebody is asking me, tell me the reaction, that is, you can also do it once you get perfection. See now, total load, 60 into 1.8 plus 100 plus half into 1.2 into 80. Calculate not on. 60 into 1.8 plus 100 plus 0.5 into 1.2 into 80. 256 down, up 256 over. Moment about A. 60 into 1.8 into bracket 0.5 plus 1.8 divided by 2 plus 100 into 2.6 plus half into 1.2 into 80 into, I'll do from that side, 4 minus 1 by 3 of 1.2, close the bracket, 584 kilonewton meter. Yes. How? I know by looking only. Clockwise 584, so anti-clockwise 584. This you start after getting perfection. The earlier solution of sigma m0, sigma v0, it is to thoroughly understand. So all the master questions, once I will solve by basic approach, systematic approach, then I will tell the shortcut method. Then I will tell, with this master questions are over, now start one by one in order, starting from one point load, somewhere out at the edge of the beam, somewhere in between, UDL, partial or full span, UVL, couples, one by one will come. So go through this class thoroughly, starting from 50. For that matter, start from engineering mechanics class number 1. If you really want to learn everything from me, by this time at least you can make out, I at least know something. Okay. Thank you. We'll meet in the next class. See, just now, I closed the class. I even told you we will meet next time. But when I went there inside and checked the recording means anything is out of the camera, I was checking that way. Suddenly I found that it is not a mistake, but I do not want it. See, go back to option 1, not option 2. This is for option 1. That is traditional solution. That is not shortcut, option 1. That is by basic condition of equilibrium. See there in the sketch I wrote VA, MA, HA like this. Then first I wrote sigma H equals 0, not required now. When I made sigma M0, sigma M about any point equal to 0, I told you always take moment about the fixed end. Reason I told there, where unknown couple is there, unknown reacting moment is there. So I told you should consider entire beam, algebraic sum of moment of the entire force system, not one side. One side is for bending moment. See, for the entire force system is 0. Then I wrote, see somewhere here I wrote, see the camera line is somewhere here, camera line. Now it is correct. Earlier the camera line was somewhere here. I wrote, see here, plus here, plus half into 1.2 into 80 into this distance, I explained already, 100 into this distance, 60 into 1.8 into 0.5 plus 1.8 by 2. This all I wrote. I told you have to look both sides. Anti-clockwise moment minus MA. For couple, there is no distance. See, forces or loads, load into distance. That into. For couple or moment, simply moment, minus MA. I put, see, by the time I wrote minus MA there, see, I wrote this way, minus MA, then I wrote 0 there. See, now see what happened there. See the camera, I think not visible for you. Oh yes, see, same thing happened there. 1 minute. See, same thing happened there. Then I did not observe it. I stopped. So those who are seeing the recording, video later or class, they will tell, what is this one? Equal to what? Equal to 0. You cannot see even. I first wrote 0 here. I told algebraic sum of moment about any point equal to 0. Then when I started writing here, I rubbed it. I rubbed it. Because once I explain, I can rub. But I forgot that I have not explained. So you write here first, missing one, 0, and here, not this way. Now I'll do one thing. See, minus MA equal to 0. Now see, camera problem. Okay, now see, partially visible, sufficient. I will make it fully visible now. So, minus ME equal to 0. Okay, therefore, when you write it, when you study and write it, here you write equal to 0, here also write equal to 0. It is not, otherwise, how you get the answer? See, anyway, I should not have told this one. I first thought I will write in the description, but so many have no patience to see description. So I added this class recording, I am adding to that one, and in the title I am writing, see the ending part. See the ending part. I will make a note there in the title so that people can see what is the ending part. Okay. Now, over. Therefore, I told you will get MA equal to how much answer? Plus 584 kilonewton meter. Okay. Sigma V0, everything was visible there. I saw it. Only I told 0. People, so many 99% people who study thoroughly from my class, they will understand. Oh, sir wrote but forgot. Here he wrote but out of camera. Now perfect. So make this correction. Okay, thank you. Next time we will meet.